Hey guys, in this video we're going to look at solving radical equations. A radical equation is an equation that contains a root. We will be looking specifically at equations that have square roots in them, although you can apply basically the same method to any particular root, whether it's square root, cube root, fourth root, whatever, okay? An example of what one might look like, you might see square root of x plus 2 minus 6 is equal to the square root of x plus 4. Okay, it's going to be set up sort of like this. You'll see some that have a single square root and then others that have two square roots. Okay, shouldn't see one with any more than that. The 2 is kind of the maximum. Okay, so in this video what we're going to do is take a look at a couple that have a single square root, and then I'm going to do a second video with one with 2, because those problems can be kind of long, okay, and I don't want to stuff all that stuff in one video. All right, so let's take a look at the next here. Forgot to pan this back up. All right, here are the steps for solving a radical equation. Your first step is to isolate the radical on one side by itself. Square both sides of the equation. Then you're going to repeat steps 1 and 2 if you have a second radical, like we did in the problem that we just took a look at. Solve the equation that's left behind. When you square both sides of an equation, what's going to happen is the radical is going to go away. So you just keep doing that until you get rid of all your radicals, and then the equation that's left, you're going to solve that. Then an important step is this last one, check the solution. This type of equation, when you do step 2, will sometimes actually produce an equation that does not work, or not an equation that doesn't work, but a solution that doesn't work. So you do have to check the solutions at the very end. That's the last thing that you do, and it's mandatory. You cannot skip the check on these, because it is, it's not common, I don't guess I would say, but it does happen that the solution that you get from the problem just does not work. Okay, let's take a look at an example. This is a real simple example here, very, very basic. We do have the one radical right here, the square root, and then on the other side of the equal sign I've just got a constant. So here's what we do. Okay, first step is to isolate the radical. Well, it's already isolated. It's by itself on one side of the equation. I don't have to move anything. Second step is to square both sides. So we take that whole square root and raise it to the second power, and then we're going to do the same thing with a whole second side, okay? Ours is just the one number, so that makes it really easy. When you square a square root, what happens? The square root and the square are going to cancel each other, okay? Those two exponents would cancel each other, because you can write a root as an exponent. They're the same thing, okay? So the 2 and the square root basically cancel each other out. We lose the root, and so what's left behind is just whatever is under the radical. That's called the radicand. Set equal to square 4, and we get 16, okay? So I don't have another root. This is all I have left. Okay, just a nice little short linear equation to solve. So go ahead and solve that for x. We add 5 to both sides to do that. So x is going to be equal to 21. Okay, so I want you to see here what's happened. We've lost the root, and then we go into something that's just a very simple equation, and then we solve that equation for x. Now we will check it before we're done, okay? You don't have to label the check, but I usually do to kind of see that I am doing something a little bit different down here. We plug 21 in exactly where x is. And then you just double check it, okay? You're checking to make sure that you've got an answer that will actually work. And so 21 minus 5, that gives me 16. Square root of 16 is 4. So we get a true statement. Okay, and if that gives you a true statement, if the check is true, then you get to keep your solution, okay? So x is equal to 21 is our answer for this particular problem, okay? All right, let's look at one that's a little bit more complicated. Still, we only have the one radical, but we've got another extra term on the side with the radical. So our first step is to move the extra term there. We want to isolate this radical. That means taking this x and subtracting it, okay? So square root, oops, of negative 7x plus 2. Subtract the x from both sides and we get negative x plus 2, or you can do 2 minus x. Either one's fine. That order doesn't matter. Now that it's isolated by itself over here, we're going to square both sides. Now I want you to pay attention to what's going to happen over here on the right-hand side when I square this, okay? But over here we already know what's going to happen, right? Same thing that happened in the previous problem. This square and this root basically just cancel each other out. And so what we're left with is whatever's underneath, negative 7x plus 2. Now watch. All right, over here, this is where a lot of people mess up, so I want you to be sure that you see this. Over here on the right-hand side, I've got a binomial squared. I don't have just a single number like I had a minute ago in the previous example. I have a binomial. Powers are not distributable over addition and subtraction, which means I can't take this power of 2 and square the x and then square the 2. It doesn't work like that, okay? It's not like when we're multiplying something through a set of parentheses and we just give that factor to each term. I can't just give this factor to each term. Exponents are distributable over multiplication and division, but not addition and subtraction. So what will happen here is instead of distributing the square power, I will have to multiply negative x plus 2 times itself, because that's really what that exponent means, right? This exponent's telling me to multiply this times itself, okay? Multiply those two together. So that's what I do. I'm going to use the distributive property, or FOIL, to work that out. So let's see, I've got negative x times negative x, that's x squared. Negative x times 2 will give me negative, whoops, forgot to change back, negative 2x. Then I get that same thing here in the middle, 2 and negative x in the middle. So negative x, negative 2x again. And then we've got 2 times 2, that's plus 4. Alright, so this little equation is going to be quadratic. I need to move everything to one side, okay? And since x squared's right here, I'll just take these two and move them over as I start combining my terms. I've got x squared, and then I'm going to have a negative 2x minus 2x plus 7x, okay? So negative 4x plus 7x is plus 3x. And then our last term there is the constant 4. Okay, now we should be able to factor that. X and x, 2 factors of 4 that will add to give me 3. That's easy enough. Okay, set both of those equal to 0. X plus 4 equals 0 gives me negative 4. And x plus 1 equals 0 is going to give me a negative 1. Okay, I will need to check both solutions. Alright, got to check both of them. So let me scoot down a little bit. Let's see, our original equation, just so I've got it down here and can see it, negative 7x plus 2 plus x equals 2. Okay, negative 7x plus 2 under the radical plus x equals 2. Okay, so we'll keep everything on the same side as we do the check. And I am checking two different numbers. We will check the negative 4 first. So I've got square root of negative 7 times negative 4 is 28 plus 2 plus x is equal to 2. Let's see. Okay, I may have a mistake somewhere. I'm going to stop the video and check and see what I've done wrong. Hang on. Okay, I apologize, but I have found my mistake, so let's fix it. You'll go back up just a couple of lines to where I have, I had squared both sides and multiplied out the two binomials. Here's where I messed up. I remember to add the 7x to both sides, but I forgot the 2, okay? So if we're going to subtract the 2 from both sides, that's going to make this a different value. And so that's going to change quite a few things. So right here, this is going to be a +2 instead of a +4, okay? And so here, and I wasn't even thinking, because if I'd been thinking when I factored it, I would have noticed that I'd messed up, because 4 + 1 is 5 and not 3. But here I was just driving right along, trying to do a little video. All right, so that's going to be a 2 instead of a 4. Okay, and that's going to change things right here. This is why it's good to check. And I'd like to say that I'd made that mistake on purpose, but that would be a lie. So I just wasn't looking at it like I needed to. All right, so that's going to be x + 2 instead of x + 4 = 0. Which will give us a different answer. X is equal to -2 is what we're going to get. Okay, so we will check that. Scoot down here. Again, I apologize for messing that up. So if I check -2, I might be able to just... Yeah, there we go. Okay, delete them instead of marking through them. Looks a little bit nicer. Okay, so what I'm plugging in now is -2. So that's going to give me the square root of -7 times -2, which is 14, plus 2, plus plug in a -2 there, so it's going to be a -2, is equal to 2. So we're going to get the square root of 16 minus 2 equals 2. 4 minus 2 equals 2, and that's going to work out. 2 equals 2. Okay, so that one's okay. We can keep the -2. And let me see if I can clean this up here a bit too. Whoops. That's okay. No, I don't want to get rid of all that, I don't think. Okay, it's not letting me erase. It's not letting me get rid of what I want to get rid of, so we'll just go back to the marked out part. All right, and then we had x equals -2. So that one works. I apologize. And then if I plug in -1, I'm going to get the square root of -7 times -1 gives me +7. And then we are adding 2 to that. And then we will have a plus x, which x is -1. So -1 is equal to 2. Square root of 9 minus 1 equals 2. This one's going to work also. So that's going to give me 3 minus 1 equals 2. 2 equals 2. Okay, that one works too. So we get to keep both of them. So x equals -2 and x equals -1. Again, I apologize about the mistake that I made. Hopefully I didn't throw y'all off too bad, but it's just because I wasn't careful and just made a careless mistake. Okay, so that's all of that, and I will go back and we'll do a one with 2 radicals in the next video.